Hello gentlemen, the purpose of this video is to start to look at inverse trig functions, and in order to do that let's start by looking at the sine curve. And this is just a simple sine curve right here. As you guys should know that the range goes from -1 to 1, and the domain is all real numbers. And so the first question is, does the sine curve of the sine function have an inverse? Well, hopefully you guys remember that in order to have an inverse, a function must be 1 to 1, which means for every y value, there's exactly one x value. We use things such as taking the derivative and seeing if it's strictly monotonic, or we can use the horizontal line test, which basically says if I draw a horizontal line anywhere on the curve, it should intersect the curve at only one point. Well, obviously, if we look at that, I could draw a horizontal line there. It's going to hit an infinite amount of times. Or I could draw one down here again. It's going to hit an infinite amount of times. So first glance at the sine function tells me that it doesn't have an inverse. But what happens if we limit the domain? And so let's do this. Let's limit the domain of the function to be -pi/2 and to pi/2, like this. Now all of a sudden we're just looking at this blue area right here. I'm just looking at that blue area. We should see that now the function is 1 to 1. Okay, and I cover the entire range between those two values. So that's why I picked -pi/2 to pi/2. I go from my -1 value all the way up to my +1 value, and I hit every point in between. Okay, so I hit the entire part of the curve here. If I do that, I'm going to see that I do have an inverse. Okay, and that inverse is, we're going to call it as arc sine. And if I draw my y equals x curve here, the red curve is going to be my graph of the arc sine function. All right, and remember, the domain and ranges of the two of them switch. So my domain for this arc sine here is going to be from -1 to 1. Okay, and my range is going to be from -pi/2 to pi/2. And these points switch. This point over here is -pi/2, -1, and this one's -1, -pi/2. Okay? And so it's important to know what the domain and range for the arc sine is, and when we use it, we know what to expect for a value. All right? And we'll do some examples there, but just quickly, I could say that the sine of pi is equal to 0, and I know that. Okay, but I can't say that arc sine of 0 is equal to pi because that's not in my domain. Okay, I'm going to get 0. If I go arc sine of 0, I'm going to get 0. Okay, not pi. Okay, because this point is outside my range when I'm looking at arc sine. Okay, hopefully that makes sense to you. We'll do some examples a little bit later in the video. But let's look at cosine and think about doing the same thing. But here, if I go from -pi/2 to pi/2, it doesn't work so well because I still don't pass the horizontal line test. And so if I'm not passing the horizontal line test, then I'm not going to have an inverse. So I'm going to change this to be 0, and we're going to go from 0 to pi, like that. Okay. If I go from 0 to pi, here you should see again, I'm 1 to 1. I cover the entire range and all the values in between, right there. Okay, so now again, I will pass the horizontal line test, and so I will have an inverse. So if I look at what the inverse looks like here, it's this red line right there. Okay, and again, you should see that points on the curve change. So this point here is the point 0, 1, and this point is going to be 1, 0. And the range is going to, the domain is going to be from -1 to 1, right in here. And my domain, my range rather, is going to go from 0 to pi. And 0 to pi, as you can see down here, is the domain of the function. All right. So this point right here on the cosine curve is pi comma -1. So it's going to be -1 comma pi on the inverse function. And again, it's important to know what values I'm going to get when I do our cosine. My values, what I'm going to produce, um, I need to know my range and my domain. And again, my domain is going to be from -1 to 1. So I've got to plug in a value -1 to 1. And the range is going to be a value between 0 and pi. So if I go arc cosine of some value x, my answer is going to be somewhere between 0 and pi. Okay? I can't get a value 2 pi or 3 pi over 2 or anything out of our cosine function. Okay, that's important to know. Let's look at one more. Let's look at the tangent function. Again, tangent goes like this. Okay? I'm going to actually look at my tangent function similar to the arc sine. I'm going to look at -pi/2, 2 pi over 2. Like that. And again, I'm going to cover everything I need to cover. These vertical asymptotes, when I start talking about an inverse, are going to become horizontal asymptotes. Okay, so if I look at what the inverse is going to look like here, okay, it's going to come in like this. Okay, here's my y equals x. It's a little bit messier here, but understand that I'm going to have horizontal asymptotes at pi over 2 and -pi over 2. The domain here is all real numbers because the range of of the tangent function, the range of tangent, is all reals. So now my domain for arc tangent is all reals, and I'm going to go from my range is going to be from -pi over 2 to pi over 2. Okay, so here is 3 examples where I'm going to limit the domain of my sine, my cosine, my tangent function so that I can have an inverse. And again, I'll reiterate the importance of understanding the domain and range. You guys should be familiar with that, but hopefully this review has been helpful.